My name's Larry DeBerk. I'm with Clearstream Environmental. We did the together with DBS. We are building the clarifiers. There'll be 8 clarifiers out there. But before I go into our equipment, I always like to go through and figure out, so everybody, half of it's from my knowledge, but where does this fit? What does your plant look like? How does it work? And how does stuff get into it, and how does it get out? So you have to tell me on this one, because I'm just going to draw it up here where the flow comes from. So first thing, when it hits the plant, what does it hit? Bar screens? Are they manual or are they?
Lately,
yeah.
Lately they are.
That was a lot of
They're not supposed to be. After about 2 months they were.
Okay, so you have some bar screens, right? Goes through bar screens. Then you have some sort of grit removal.
Yeah.
What's your grit removal? I mean, is it a vortex grit separator? Is it an aeration chamber? Is aeration?
Yeah.
And then you have some sort of buckets that.
Yeah. That would be apart.
And then where does it go? To the primary. Do you have primary clarifiers?
Yeah.
Are they rectangular? Okay, so you have some rectangular clarifiers up front that are some sort of chain and fly rectangulars or something or other. Grit the solids out of there, and that goes to aeration. Just an aeration basin. So we have bubbles coming out of there. Are they fine bubble diffusers inside of it, or? Okay.
Both.
Okay, from there, then I guess it goes to these clarifiers, right? These secondary clarifiers. And you have an inboard launders on these, and these rasp pipe takeoff parts. Oh, so this comes in the bottom here. Comes up through the middle, in the clarifier. Okay, where do your underflow, what does the underflow go to?
Return and waste.
Okay, oh, so you have both the RAS and the WAS here. How do you waste your solids? Oh, you incinerate it? Okay, so the WAS goes to incineration, and then the RAS gets recycled back into the aeration basin, right? About what percent of recycle do you do? 80%?
Varies.
Okay. What kind of mixed liquor do you maintain here? 3,000? I mean, 3,500, is there a magic number you try to maintain?
We're shooting for 41.
41?
I mean, once we get into the new tanks and then we'll, the return rate's gonna vary.
Okay, so I don't know, 50 to 75%
Yeah,
or
that's-
something like that
Yeah.
of a recycle, right? Okay. And then the overflow out of here just goes to some chlorination or UV or something or other?
Contact chamber.
Okay. So that's what Clearstream is mainly this secondary clarifiers right there. Of course, this is a pretty rendering of what you have out there. There's no crap on it, nothing is perfect. But it doesn't have these baffles, the lower submerged well in it. And we'll talk about that, how that's going to affect the overall process. But anyway, I'm with Clearstream. I've been in this business for, mid-80s, something like that. I've been a contractor, a consultant, and a manufacturer for quite a while, mainly manufacturer of equipment. So we do all kinds of clarification, thickening, softening, flotation, just about any type of circular clarifier that they have. So this is your clarifier right here. And that's the drawing the main drawing you have up there. But anyway, if you look through, your flow is going to come through the center here and go up the center column and out underneath I call it a RAS box. I'm not sure what your official term is. But it comes out underneath the RAS box through slots in the center column and is fed into the feed well. It goes underneath the feed well, the general flow will go underneath the feed well, up and over this submerged baffle, and then flow out and up into the launder and out the weirs, okay? The solids will collect along the bottom, and they collect in these V, the blades are set in a V, and it collects it towards these RAS pipes. The RAS pipes pull up the solids through hydraulic differential into the RAS box here, and there's separate gates for each pipe, so you can adjust those, and I will jump to a slide in a little bit anyway. And then the solids that are collected here go down through the center column and out again. So the center column has both the influent coming in and the RAS going out. And I believe it's the same way you have your existing ones that way. In the very bottom, there is two holes that bolted on plate that you can take apart, and there's a Fernco coupling that ties that together. So that's the seal for the RAS pipe in the middle. Okay. Then the floating scum is it's collected along the whole top by this arm. Well, there's two arms. It'll collect everything and dump it into one scum box. One humongous, big, long, freaking scum box. So, and it'll dump everything into there, and then it goes to however you process your solids. There's a box on the side. I don't know how you get the solids, where they go to, the floaters.
There's a pipe and it goes up to the scum well.
Yeah, there's actually a box on the side right here that the walkway's on top of.
There's a little pipe
And then is it
coming out there.
pumped out?
Yeah, they get post pumps for the scum.
And then that's treated.
So,
Yeah.
right
Oh,
to
you
the-
send it over to a DAF?
Yeah.
Okay, and float that off, and then, okay. And then it's mixed with the burned off also?
That's all.
Okay. Okay, so how it operates shouldn't be much different than what you have, except for a couple of things. The submerged baffle well, and probably the way we have our gates inside the thing. So, this is a side view. Maybe shows a little bit better your influent coming in, the RAS pipe going out. There also is a way to draw sludge off of the center. It's not straight to the center, it's straight to D notches, but there's still a drain, that pipe's still in there. And then there's the individual RAS pipes. 3 inside this well and 4 on the outside. And then these valves on top, each one's individually controlled, each pipe there. So you can shut it off or adjust your flows inside of that.
What kind of valve is that?
It's, well, I'll show you I'll get to it in about 2 things here. We did some, I call them expensive guesses to figure out where your sludge is going to distribute through the bottom of the clarifier, particularly with this baffle wall. This shows half a clarifier basically. This is the column it's coming up, and these are kind of gradient lines. And it's showing that the hydraulics going through. This is kind of a weird point that I don't know where that came from, but it still shows. This is the different hydraulics that's through the tank. It's relatively high velocity, high meaning, quarter foot per minute. I mean, it's really slow, but it still shows a gradient through there. So based on that, we tried to figure out where these solids are going to go. Our first guess, and you'll have to look at this, is that the solids are going to pile. This, it's stretched here, obviously. And this is just the bottom, but this is that submerged baffle right here. This is your center column here, that it's going to pile like this inside and pile up against this wall, go over it, and then like snow on the back side of a fence, pile up there again, and then trail off to almost nothing on the outside. So depending on your solids loading, obviously, and how fast you draw off your solids and stuff like that. This is our best guess. We don't know exactly how it's going to do. I mean, like I said, it's an expensive guess on here, running some hydraulic studies and things like that.
So obviously the draft tubes nearest it, you're going to make certain that those are running, just assuming that this is how the sludge is going to be hitting
Right.
the tank. And I also understand that submerged baffle wall is optional. It's possible that we may end up taking it out if it doesn't work.
Could be, could be. The pipes actually are larger on both sides of this they're 10 inches here and they're 8 inches across everything else. So we thought that, we felt that the up front here probably, I don't know, again, it's a guess, half the sludge is gonna pile on this side and this side or something like that.
Do some profiling with the sludge judge during the initial
Yeah,
startup.
and again, we ran some hydraulics and did a best guess at what the settling rates were and things like that. And then a lot depends on how fast you take it off and things like that too. So you'll have to, I think the first few months is you just have to find out what it looks like. Because again, this is an expensive guess, that's all I can say on the thing. So to the gates, there are, if you look at the top of the drawing here, there's 7 pipes that come up to each one of these gates. And then, I don't know if they are labeled, but we'll try label, is it better to go 1 being the inside?
Doesn't matter yet.
Okay,
Do whatever you want.
Actually, as long as it's consistent.
that's what I mean, it'll be 1, 2, 3, 4, 5, 6, 7, and it'll just be, so we have them labeled, because they're not like, this is 1, 2, there's 2, 3, and 2 when you get out on there. Now, if you notice from here, let me go back up to that drawing. To adjust the gates, you actually the other drawing's better. There's a ladder, this is a ladder right here. You actually step down and there's grading about right here. So you'll come down into here, and this work kind of as a handrail idea. So you'll step down, there's grading there, and then you have access to every individual gate, okay? And this is a submerged gate that we open an orifice on the very bottom of it. Now the scale will reach a 0 to 100%, okay? Because depending on what you pump your RAS at, if that changes, then the flow rate will obviously change. But it'll stay consistent from unit to unit. Depending on how much you open this up, if the very end one you only need 3% flow through it, then you'll only open it at a small amount. But if you pump more RAS, it'll obviously pump more, the same percent will come through that. So they're a submerged orifice portion. Now we also included a little hole in the top, for lack of a better. You can actually run these gates lower so you can flush out any scum that might come up, build up in top of this box. And so you just drive the gate past closed. If you, on the side here, it'll have 0 closed up to 100%, and then it'll be a flush. There's a guide on here, you come down, you hit flush, and that'll be, so this gate's there, and it'll flush out. Basically, it'll even out with the outside of the clarifier, and you can flush out scum that will build up on top of that. You can also test, each one is its own separate thing, so you can actually test each one to see what your solids concentration is coming up through each individual pipe. So you can see if you've got a really dilute feed versus a high concentration, and change and adjust your flow based on
So
that
you
stuff.
would just dip a sample and do a spin down? Or
Yeah,
would you
well, no,
recommend-
you can actually just dip inside of there, in each gate. Each one of them is accessible. Oh, do I have a good drawing of that?
But I mean, to determine a solids, then what would you recommend, a spin down with a centrifuge, or just?
Oh,
Just
however
put
you
solids?
do it, cook it, when you run your mixed liquor, however you determine your mixed liquor concentrations, you can do each individual one and see how concentrated it is, or how dilute it is. Or just actually set up an IHOF cone to do your SVIs, and you can look at it quick that way too, to see the volume you get through there, rather than waiting a day or two to cook it. But I think you could use that way to balance also all your parts, so you're not getting a very dilute stream from the outside and a very concentrated stream from the inside also. This is going to take 3-4 months, I think, to balance these out to get what's going on there. I don't know any other way, because it'll take, if you make some adjustment, it may take 3 or 4 days to kind of adjust itself to what your new adjustments are. So, it's just hard to predict from our side. I think using your other ones, don't you shut off every other one on the existing ones or something like that? Well, you may have the same thing here, that it may be something similar to that, so. In your, there are handles to open and close there. And then there also is in your spare parts thing a nice 36-volt drill that you can just open it with that too. It's much faster than the handle one.
So each one has a handle, or you gotta take the handle and move it?
No, each one should have a handle.
Nice.
I don't know where they're at, but there's also one drill motor.
But those handles are always on there, or you gotta take them off?
Oh, there's one per clarifier.
He's got the drill.
Okay.
Yeah, there's not 14 of them.
Okay.
There's one per unit.
Alright.
But there's a drill motor that has a bit that attaches to it that you can run these gates up and down a heck of a lot faster than by hand. So from the scum, we'll show you that as we go through. I was going to go through just the basics of how this drive works and how it's different, and then we'll go into the O&M in a little bit here. So the drive is built a little different. It's a hydraulic driven drive unit instead of an electrical and mechanical one. And it also has a bearing on it that's, it's DBS's 5-year no maintenance main bearing. Okay, so the drive is basically, instead of running a ball bearing itself, this drive unit actually runs on a plastic bearing per se. And let's see, I thought I had one. Oh, there is a drawing just in front of their big drawing like this. Well, this one has it on it too. And so does this one here in the DBS. This is basically this drawing right here. This bearing is, and it's easily replaceable too. There is a UHM bearing plate right here, and then a bronze impregnated bearing that's on the outside. So this thing actually slips on top of this bearing plate. And they still have their long life, but this UHMW is a self-lubricating bearing. So there's no condensate to drain on this. You don't have to worry about condensate buildup inside of it. It's a grease lubricated pinion gear, and that grease is enough to obviously keep it going. And actually a little moisture in it just helps lubricate the overall unit itself. There's some weep holes. There's no condensate to drain, so that'll be quite different than any other type of unit you're used to. And so that's this bearing right here. And then in the O&M manual, I'll show you if it ever goes, if it ever wears, which it should have easily a 20-year life to it. Using these jacking bolts, you can actually take this out and replace it in about a 4-hour period, these bearing pieces. So the upper portion is built up a hydraulic drive unit. This is the torque box. This is the hydraulic drive. It's all self-contained, so